You've probably noticed it. Early in the morning, before the sky fully wakes, when a cold streak of light breaks through the eastern horizon. Or late in the evening as the sun dips below the horizon, leaving a fading glow behind. And in that stillness, a single point burns bright. It's not a star. Stars always flicker. They're too distant, too shy. But this one hangs in the sky like a diamond nailed in place. No flicker. Just steady, confident, blinding light. The morning or evening star. Aside from the sun and the full moon, it's the only object in the sky that makes you stop, tilt your head back, and forget everything else. Its glow greets you before dawn and bids you farewell as the day slips away. Behind this moment lies real physics. The light is so intense it defies everything we're used to. We live in cities bathed in electric glow and have long forgotten what a true night sky looks like. But if you venture far from the lights, into the mountains or deep wilderness, where the air is pure and darkness thick as ink, something almost unbelievable happens. Venus, at its brightest, casts shadows. They're faint, blurry, but undeniably there. From your fingers, from branches, from stones. Shadows drawn by the light of another world. And if you're lucky enough to be by a quiet lake, a silver path appears on the water. Just like moonlight, one tiny, distant world floods our planet with its glow. But beneath this beauty lies one of the toughest mysteries in our solar system. We're about to see how awe quickly turns into shock. You'll discover why the clouds there aren't made of water, but of concentrated sulfuric acid. Step by step, we'll follow the story of Soviet landers, the only machines in history to touch its surface and survive, even if just for a few minutes. You'll witness those very images sent back from a hellish world, where the pressure crushes at 90 times that of Earth, and the heat melts lead without breaking a sweat. This isn't just a tour behind a dazzling veil, it's a glimpse into a world that warns us all. For centuries, people have looked up at the sky and saw nothing but perfection in that sparkling jewel. The Greeks called her Aphrodite, the Romans Venus. Her name always belonged to the goddess of love, beauty, and fertility. This myth was so resilient that for hundreds of years we believed a cozy world hid beneath those clouds. Almost like our own, maybe even better. We called her by the name of the goddess of love for centuries. But how did a planet once thought to be Earth's twin turn out to be its complete opposite? At first glance, it seems absurd, a cosmic mistake. When astronomers lined up 4 rocky planets, Mercury, Venus, Earth, and Mars, they noticed a pattern. 2 small worlds on the edges, Mercury and Mars, and 2 nearly identical ones in the middle, like they came off the same assembly line. Venus and Earth. Their sizes are almost the same. Their masses differ only slightly. Hold them in your hands like 2 billiard balls, you'd struggle to tell which is heavier. Gravity on Venus's surface is about 90% of Earth's. A person standing there would feel only a little lighter. This isn't just a coincidence, it's almost a perfect mirror. 2 planets born from the same stellar material, orbiting side by side, starting with nearly identical conditions. One became the cradle of life. The other turned into a scorching desert. The key to this wild difference lies in a concept that sounds like science fiction, but is a harsh reality. The habitable zone. It's not a specific place, just an imaginary belt around a star where it's not too hot and not too cold. The perfect distance where water can stay liquid, neither boiling away nor freezing into eternal ice. Earth sits right at the center of this zone. But here's the paradox. The zone isn't fixed, it moves. Our sun, like any star, grows hotter over time, pushing the habitable zone outward, away from the rising heat. Billions of years ago, this zone lay closer to the sun, and Venus probably stood right at its heart. It's more than just a hellish world. It's a fallen paradise, a planet that once had a chance. Conditions that could have formed oceans, clouds, and maybe something more, but something went wrong. The first clue in this cosmic mystery is the atmosphere. Earth's air feels almost weightless to us. We move through it without a second thought. But Venus's atmosphere? It's something else entirely. It's a gas ocean, almost 100 times heavier than Earth's. That number is hard to grasp. So try this. The pressure on Venus's surface matches what you'd find a kilometer beneath Earth's oceans. Pressure strong enough to crush a modern submarine like a tin can. Every square centimeter of Venus's surface bears the weight of 92 kilograms. as if an adult man stood on your thumbnail. This isn't just a difference in weather. It's a fundamental divide in the physical nature of a world. Two planets alike in mass, one wrapped in a light gaseous veil, the other swaddled in a leaden blanket weighing 465 trillion tons. This blanket has a direct consequence. Look at Earth from space. A living sphere, the deep blue of oceans, white swirls of cyclones, green and brown patches marking continents. Our planet faces the universe openly, its appearance constantly shifting. Now turn your gaze to Venus, a flawless, smooth sphere in creamy yellow, not a single feature. No continents, no oceans, no craters. Its surface lies hidden beneath a dense, impenetrable layer of clouds, a perpetual global veil that never parts. It's as if the planet deliberately hides its face. Beneath that smooth, serene mask lies the most violent climate in the entire solar system. For centuries, this shroud wasn't just a mystery to scientists, it was a blank canvas for dreamers. This blank space on the map, this smooth surface in the telescope, it called out to us, it fired up the imagination. If we can't see what's there, then anything is possible. People stared into that impenetrable veil and filled it with their own hopes. Lush jungles, warm oceans, exotic civilizations. Beneath those clouds hid not just another planet, hidden there was the dream of an entire generation, destined to collide with harsh reality. To grasp just how devastating the truth about Venus was for humanity, we first need to feel that dream, that grand illusion we built over centuries, one destined to be shattered by reality. Before the space age, Venus was more than a bright dot in the sky. It was a promise of a second home, a young Earth bursting with life. In the pages of science fiction from Vladimir Vladko to Alexander Kazantsev and the Strugatsky brothers, this world took on flesh and blood. The air there was thick and warm, like inside a greenhouse. Dim sunlight filtered through a never-ending fog. Beneath your feet, endless swamps squelched. From the poisonous green thickets of giant ferns, the roars of creatures long extinct on Earth echoed. It was a Jurassic world, frozen in time. This wasn't just a flight of fancy. The vision stood firmly on the best science of its day. Scientists followed a simple, flawless logic. Venus sits closer to the sun, so it must be warmer. It's shrouded in thick clouds, so it must be humid. Warmth and moisture. Those are the hallmarks of Earth's tropical zones taken to the extreme. Researchers imagined a vast, endless rainforest or even an unbroken ocean. This wasn't a mere hypothesis, it felt nearly certain. Venus appeared as a young Earth, going through the same evolutionary stages our planet once did. When we looked at it, we didn't see a distant alien world. We saw our own past, alive and breathing right next door. This dream became so vivid, it could be seen on the screen. In 1961, right at the dawn of space travel, director Pavel Klushantsev released the film Planet of Storms. It brought to life everything a whole generation believed in. Soviet cosmonauts trudged through thick, sticky soil, battled prehistoric reptiles, and pushed through misty jungles. For millions of viewers, this wasn't just a fairy tale, it felt like a near-documentary prediction of what we were about to discover. The film cemented the image of Venus as a humid, living world in the public imagination. It became a monument to the greatest misconception in the history of space exploration. A monument to a hope that was fading fast. So why did this illusion last for so long? The answer is paradoxical. It's because Venus is so close. As an inner planet, it's squeezed between us and the sun. From Earth, we can only catch glimpses of it during brief windows. Either at dawn, when it rises ahead of the sun, or at dusk, when it follows the sun below the horizon. The rest of the time, it's drowned out by the sun's glare or lost against the daytime sky. It's like trying to see details on a light bulb next to a blinding spotlight. But that's not the main challenge. Venus, like the moon, goes through phases. And the cruelest trick of cosmic geometry is that when it's closest to Earth, it turns its dark, unlit side toward us. The perfect view of a black disk. This veil of mystery, woven from sunlight and the geometry of orbits, became fertile ground for myths. Gaps in our knowledge filled with imagination. For centuries, we gazed at these clouds and saw only reflections of our own hopes. But in 1761, one man looked closer and saw not clouds. He saw the truth. This is Mikhail Lomonosov. The year is 1761. Across Europe, astronomers pressed their eyes to telescopes, eager to witness a rare event, the transit of Venus across the face of the Sun, a tiny black dot crawling slowly over our star's surface. For most, it was just a chance to refine the distance to the Sun, and nothing more. But Lomonosov, in his modest observatory, saw something everyone else missed. The moment Venus's disk just touched the Sun's edge, and then began to slip away, he noticed something strange. Not a sharp black edge alone. For a split second, a thin, faint glowing ring flared around the planet. He called it a bulge. It wasn't a reflection, it was refraction. Sunlight bending as it passed through a gaseous envelope, creating a fiery halo. The first undeniable proof in history of another planet's atmosphere. The breath of an alien world, caught by the eye of a genius. This tiny bubble, spotted 250 years ago, unlocked a whole new universe. Today, the method known as the Lomonosov effect stands as a crucial tool in the search for life beyond our solar system. When we point our most powerful telescopes at distant stars, we wait for the very same moment. We watch for an exoplanet, a world trillions of miles away, to pass in front of its sun. And if at that moment a glowing halo appears around the dark disk, scientists around the world hold their breath. It means the planet has an atmosphere. And where there's an atmosphere, there could be everything else. One observation through simple glass became a bridge across centuries, linking a modest observatory in St. Petersburg to the quest for humanity's second home. It seemed the first great secret of Venus had been uncovered. It has a vast atmosphere, a sort of air ocean. But this victory was only the prelude to a far deeper shock. In the 20th century, radars emerged that could pierce through the planet's thick cloud cover. They delivered data so bizarre it looked like a mistake, a physical impossibility. Venus rotates on its axis unimaginably slowly. One full spin takes 243 Earth days. Meanwhile, its year, the time it takes to orbit the Sun, lasts just 225 days. That means a single day on Venus is longer than its entire year. Imagine walking forward on an escalator moving faster than you. You take a step ahead, but end up falling behind. Yet even that isn't the strangest part. Venus spins in the opposite direction. Every planet in the solar system except Uranus rotates one way. Venus goes the other. There, the Sun rises in the west and sets in the east. This discovery shattered everything we thought we knew. But what came next was even more astonishing. The atmosphere that Lomonosov uncovered moves with a life entirely its own. It doesn't obey the planet beneath it. While Venus's solid surface slowly turns, completing one rotation every 243 Earth days, the upper cloud layers race around at hurricane speeds. They circle the entire planet in just 4 to 5 Earth days. Scientists call this phenomenon superrotation. The atmosphere spins 60 times faster than the planet itself. Imagine the air in your room suddenly taking off, roaring past you at the speed of a jet fighter while you stand still. This defied every known law of planetary physics. A slow, nearly motionless planet spinning beneath a wildly turbulent, hurricane-like atmosphere. This contradiction shattered everything we thought we understood about energy transfer. What invisible engine drives this endless global storm? And what exactly are the clouds made of, hiding the source of such incredible power? The secret behind the planet's wild atmosphere didn't come from mechanics. It came from chemistry, from understanding what those clouds which have teased and deceived us for centuries are really made of. They aren't made of water, not a drop. That bright, glowing veil reflecting the star's light is concentrated sulfuric acid. Droplets of a caustic, flesh and metal-eating substance drifting in the upper layers of this vast air ocean. The dream of a tropical paradise, a Jurassic world, died instantly. In its place rose a vision pulled straight from Dante's pages. This aerial ocean turned out to be more than just poisonous. It was monstrously dense and made up almost entirely of a single gas. 96.5% of Venus's atmosphere is carbon dioxide, the very same gas we exhale. The remaining 3.5% is mostly nitrogen. But because of the crushing density, even that small percentage means there's more nitrogen on Venus in sheer volume than in Earth's entire atmosphere. It's a suffocating, heavy, thick environment, more like a liquid than a gas, and it follows its own brutal set of rules. Venus's slow rotation simplifies its weather system to the extreme. No complex fronts, no shifting cyclones. Each hemisphere hosts just one massive weather system, one endless, relentless cyclone. Air rises at the equator, rushes toward the pole, cools down, then sinks into a giant polar vortex to start the cycle again. A global conveyor belt spanning half the planet, a single Hadley cell running non-stop for billions of years. This is where logic breaks down. A paradox emerges, one that baffled scientists for a long time. Take Mercury, for example. It orbits much closer to the Sun, a dark, nearly black sphere that reflects only 7% of the sunlight hitting it. It greedily soaks up almost all of the star's energy. Now look at Venus. It's farther from the Sun, and it shines like a dazzling white mirror. Its clouds made of sulfuric acid reflect 90% of the sunlight right back into space. It barely absorbs any heat. By all the laws of physics, Venus should be an icy world, while Mercury should be a blazing frying pan. But reality flips that on its head. Mercury's average temperature barely reaches 150 degrees Fahrenheit. Venus scorches at 900 degrees, hot enough to melt lead. How does a planet that acts like a mirror end up hotter than the one that greedily drinks in the sun's heat? It looks like a mistake, but it isn't. The secret lies in a mechanism that transformed our sister planet into a hellish furnace. It's an irreversible greenhouse effect pushed to its breaking point. The principle is almost laughably simple. Imagine a car left out under the sun. Sunlight consists of short, high-energy waves that easily pass through glass. The seats and dashboard absorb this light, heat up, and start radiating that heat back, but now as long, low-energy infrared waves. For these long, sluggish waves, the glass turns into an unbreakable barrier. They get trapped inside. Energy flows into the car but barely escapes. Every minute, the interior grows hotter and hotter. Now, replace that glass with an atmosphere made of carbon dioxide, hundreds of kilometers thick. That's Venus. About 10% of visible light slips through and heats the surface. But the long heat waves radiating from those scorching rocks become trapped. Carbon dioxide acts like an impenetrable blanket. Heat builds up. For centuries, millennia, millions of years. This effect isn't some exotic phenomenon. It exists right here on Earth, and it's absolutely essential. Without our much more modest greenhouse effect, the planet's average temperature would drop below freezing. The oceans would turn to ice. Our carbon dioxide blanket adds about 40 degrees to the global temperature, making life possible. On Venus, that same blanket adds 500 degrees to a temperature that should already be above zero. That turned the planet into a furnace, an autoclave, a place without seasons, no cool nights, no difference between the equator and the poles. Just endless, suffocating, uniform heat. Pressure 92 times greater than Earth's, enough to crush a nuclear submarine. Temperatures that melt lead. Acid rain made of sulfuric acid in the upper atmosphere. Knowing all this, the Soviet Union decided to send a human there, or rather a mechanical avatar of a human. This was no ordinary scientific challenge. It was a full-scale siege. The Soviet Union, already accustomed to dominating space, launched the first probes to Venus with the same confidence that followed their orbital triumphs. These spacecraft were engineering masterpieces, built to endure any cosmic trial. But space and Venus are two completely different worlds. The early Venus probes plunged into thick clouds while engineers on Earth tracked every signal. Then silence fell. Communication cut off at a tremendous altitude, long before the probes reached the surface. At first they blamed defects or random failures, but when one probe after another went silent at the very same spot, one thing became clear. This wasn't a malfunction, it was a pattern. The planet was fighting back. It destroyed Earth's emissaries without even letting them touch its surface. Scientists had no idea just how brutal this world would be. Their calculations predicted pressure of 10, maybe 20 times that of Earth's atmosphere. But reality shattered those expectations, reaching nearly 100 times Earth's atmospheric pressure. That's like diving a kilometer deep into the ocean. When the first probes entered this blazing, crushingly dense soup, they simply collapsed. Their hulls, designed to operate in vacuum, burst like fragile balloons. Metal warped, electronics crumbled to dust. Venus ground them down without so much as a trace. Humanity sent its finest creations into the abyss, and it crushed them like empty tin cans. Soviet engineers took an unexpected and brilliant approach. They realized that reaching Venus wasn't about building a spaceship. It required designing a deep-sea submersible, but instead of diving into water, it had to plunge into an ocean of carbon dioxide. They had to forget about aerodynamics and lightweight alloys. The new Venus probes looked more like armored vaults. Perfect spheres, so pressure would press evenly from all sides. They built titanium hulls with incredibly thick walls. Layers of thermal insulation protected against 465 degrees Celsius, the kind of heat that melts lead like water. This wasn't just a probe anymore, it was a bunker sent straight into the furnace. The strategy paid off. These new fortress-like probes pierced through the acidic clouds, pushed past the deadly limits that doomed their predecessors, and kept sending back telemetry. Pressure soared. Temperatures skyrocketed. Yet they held strong. Then, in 1970, something happened that forever changed the course of space exploration. Venera 7 touched down. For the first time in human history, a man-made craft made a soft landing on another planet. A triumph that still stands alone. The Soviet Union became the first and only nation whose probes operated directly on the surface of Venus. But the landing was just the beginning of a new race. A race against time and relentless physics, eager to burn the probe alive. The heat shield could only delay the inevitable. The engineers had at most an hour, maybe an hour and a half. In those precious minutes, the probe had to transform into a fully functional automated laboratory. A tiny drill bit into the scorching ground, untouched by sunlight. Rock samples were drawn inside for chemical analysis. Streams of data about the soil's composition, temperature, and pressure blasted across millions of miles of vacuum toward Earth's antennas. Every second counted like gold. Every byte sent back was priceless knowledge wrested from a hostile world. They held on. They touched down on the surface. And they opened their cameras. The entire world held its breath, ready to see for the first time what the bottom of this hell really looked like. And then they arrived. Not all at once. One by one, painfully slow, pixel by pixel, line by line. On the screens in the Soviet Mission Control Center, a new world emerged from the chaos of static. The people who hadn't slept for days, the engineers whose calculations withstood unimaginable pressure, held their breath. Decades of dreams, years of relentless effort, failures and triumphs, all converged in those dim black and white lines. The image flickered, but with every passing second it sharpened. Horizon, rocks, cracked, scorched earth. These were the first and only panoramic pictures ever taken on the surface of Venus. Dreams of swamps and dinosaurs, of humid jungles and boiling oceans, all of it burned away, reduced to ash. Reality proved harsher, simpler, and far more alien. Before the scientists stretched a rocky desert, bathed in a strange, otherworldly light. Everything around them glowed orange. The sky, the stones, the ground itself, all in shades of rust and amber. This color wasn't a property of the rocks. It was an illusion crafted by the atmosphere itself. Venus's thick 100-kilometer-deep air acts like a giant filter. It eagerly absorbs blue and green light, letting only the faint traces of yellow-orange reach the surface. Standing there felt like being at the bottom of a deep ocean where only dim, distorted light breaks through. But beneath their feet, there was no sand or mud. Analysis showed that the soil at the landing site was almost identical to Earth's basalts. Solidified volcanic lava, familiar geology, and utterly unimaginable conditions. Even amid this triumphant flood of data, space had its own sense of irony. On the panorama sent back by Venera 14, everything seemed to go perfectly. The camera opened. The protective lens cover was fired off and dropped onto the surface. Then the soil analysis tool, a tiny penetrometer designed to measure the hardness of Venusian rocks, descended right on target. It began collecting data and transmitted sensational results to Earth. The soil's hardness turned out to be remarkably similar to that of titanium alloy. The Mission Control Center fell silent. Then someone realized the truth. This million-dollar spacecraft, having survived a journey across half the solar system and a descent into hell itself, had precisely lowered its instrument onto its own lens cover. studying with diligent precision the earthly material it had brought along. The greatest scientific achievement had collided with the most mundane law of Murphy's. The real shock was yet to come. After the initial excitement faded, scientists began to study the panoramic images in detail. That's when one of them spotted something unexplainable. Planetologist Leonid Conferman examined the photos frame by frame and noticed anomalies, features that shouldn't have been there. One picture showed an object with a complex structure. Just minutes later, in the next shot, it vanished. Elsewhere, something appeared that resembled a tail and claws. The scientist gave it a nickname, the Scorpion. Conferman suggested these cameras didn't just capture rocks. They might have caught a form of life, one able to survive in these extreme, almost alien conditions. The scientific community met this hypothesis with intense skepticism. Most dismissed the scorpion and other features as image defects or tricks of light and shadow. Yet, the images didn't disappear. They are real, and they do show details that seem to appear and vanish. The xanthomality hypothesis never gained acceptance, but it did something more important. For the first time, it brought the question of life on Venus out of science fiction and onto the table of scientific analysis, backed by actual data. It was the first ghost, the first shadow of doubt that forced us to ask, have we really understood this world? These rare images gave humanity its first priceless glimpse of a neighboring planet's surface. But they were just tiny islands of knowledge in a vast ocean of mystery. Those photos from the surface offered only a peek through a keyhole. To see the whole world, we had to climb higher. And not just climb, we had to pierce through the clouds with an invisible gaze. Photos from the landing modules were just tiny dots on a vast, invisible map. To truly understand the world, we had to see it as a whole. The first step wasn't down toward the scorching surface. It went sideways into the ever-raging clouds above. The Soviet Vega program represented a pinnacle of engineering genius. This combined mission tackled incredible complexity. The spacecraft didn't just study Venus. They also used its gravity to sling themselves toward intercepting Halley's Comet. But it was the Venusian part of the mission that forever changed how we explore other worlds. For the very first time, humanity sent airships, actual hot air balloons, into the atmosphere of another planet. These probes didn't plummet into the abyss. They became part of the planet itself. After detaching from the landers, the balloons filled with helium and hovered between 50 and 54 kilometers above the surface. Up there, in the upper cloud layer, hell retreats. The pressure nearly matches Earth's, and the temperature feels like a warm summer day. In this relatively calm zone, 2 Earth emissaries caught in a hurricane wind drifted for 2 days through the alien atmosphere. They silently sailed over a hidden world, measuring temperature, pressure, and cloud composition. They sent back to Earth data unlike anything before. This wasn't a storming assault, it was reconnaissance. A poetic gesture proving that Venus isn't just a planet to conquer, but one to explore by drifting along its acidic rivers. But even these flights didn't answer the biggest question. What lies beneath? Beneath a 50-kilometer thick veil of clouds, the entire surface of the planet remained a blank spot, a mystery wrapped in an enigma. Ordinary telescopes and cameras couldn't help. Light that might have revealed continents and oceans never reached the ground. It bounced off the dense cloud cover, leaving us no chance to see through. To uncover the unseen, we needed a completely different kind of vision, a vision capable of piercing through matter. That vision came in the form of radar. The Soviet spacecraft Venera 15 and Venera 16 were the first to be equipped with this invisible gaze. They didn't take photographs. Instead, they probed the planet with radio waves, methodically scanning it from orbit. They managed to create the first detailed map of the northern hemisphere, about a third of the entire surface. For the first time, the outlines of mountains and plains emerged from the fog. The American spacecraft Magellan finally pulled back the veil. From 1990 to 1994, it patiently orbited Venus again and again, crafting a global, detailed map of almost its entire surface. It was a colossal effort. Millions of radio pulses sent down and bounced back came together to form a seamless picture. When the last white patch filled in, humanity held its breath and saw, for the first time, the true face of Earth's twin sister. It was scarred. Before us lay a geologically violent, fierce planet. Hundreds of thousands of volcanoes, ranging from tiny cones to massive shield mountains, blanketed its surface. Lava flows stretching hundreds of miles painted intricate patterns across the landscape. The scale of this world stunned me. On the map, Maxwell Montes stood out, a mountain range with peaks soaring 11 kilometers high. That's more than 2 kilometers taller than Everest. Next to them, Earth's tallest peak would look like a mere hill. The planet's atmosphere, a dense, heavy ocean of carbon dioxide, acted as a reliable shield. Only large meteor craters scarred the surface. Smaller space rocks entering this thick air didn't stand a chance. They burned up completely, vanishing before they could reach the ground. Venus simply doesn't allow cosmic debris to get close. As scientists explored this astonishing new map, they faced a challenge: naming all the mountains, canyons, and plains. From this challenge, a beautiful tradition was born. Since the planet carries the name of the goddess of love and beauty, they decided to give almost every feature a female name. That's how Ishtar Terra and Aphrodite Terra appeared on the map of Venus, along with Baba Yaga canyons and Snow Maiden plains. An entire world named after goddesses, heroines, and remarkable women. With one exception. The tallest mountains, Maxwell Montes, bear the name of a man, the Scottish physicist James Clerk Maxwell. This wasn't an act of sexism, it was a tribute. Maxwell developed the theory of electromagnetic waves, the very radio waves used to create this entire map. The man who gave us a way to see the invisible remains forever on the summit of the world he helped reveal. Step by step, from daring landings and graceful balloons to the all-seeing eye of radar, we have finally pieced together a complete portrait of Venus. We mapped its scars, measured its mountains, and unraveled the rules of its brutal climate. It took decades and billions of dollars to peer beneath those clouds. Yet a recent discovery proved that sometimes, all you need is to fly by with the right camera. The era of great discoveries didn't end with the last signal from Magellan. It simply shifted gears, growing quieter, more methodical. Once the main maps were complete, permanent observers stayed in orbit around Venus. From 2006 to 2014, the European probe Venus Express kept a constant watch on the planet's south pole. It meticulously studied a massive swirling cyclone that controls the weather across the entire world. When Venus Express left, the Japanese spacecraft Akatsuki took over the mission. It still operates there today, the only messenger we have circling the morning star, tracking the movement of its acidic clouds. This probe dives deep into Venus's hellish weather, sending back data without which we can't truly understand how this storm-ravaged world breathes. Science didn't stop exploring. It shifted into a mode of slow, careful observation. In the 21st century, Venus stopped being just an object of study. It became a vital tool, a gravitational slingshot. This massive planet acts like a perfect cosmic catapult. Spacecraft headed toward distant or scorching regions of the solar system use its gravity to speed up or adjust their orbits, saving precious fuel. Probes fly close to Venus, curve around it, and then shoot off like stones from a sling toward new destinations. This technique gets us to Mercury and even to the Sun, making Venus a crucial stop on interplanetary routes. And one of these transit spacecraft made an unexpected discovery, something no one saw coming. This is the Parker Solar Probe. Its primary mission targets the Sun, more specifically, plunging into the star's blazing corona, a place no human-made object has ever reached. Venus served only as a stepping stone on its path toward extreme heat. During one gravity assist maneuver, the probe passed over the planet's night side, sinking into complete darkness. Engineers decided to activate one of its cameras just in case, expecting nothing more than a black screen. But the sensor, designed to handle the dazzling plasma of the solar corona, picked up something unexpected. A faint, ghostly glow penetrated the thick layer of clouds. What we saw was thermal radiation coming from the surface itself, cutting through 50 kilometers of atmosphere. It looked like glowing embers shining faintly behind thick smoke. For the first time, humanity glimpsed Venus at night, not through radar reflections, but in its own light. The images were blurry, yet the dark shape stood out clearly. This revealed the Aphrodite Terra, a vast mountain range. The highlands were slightly cooler than the surrounding scalding lowlands, so they appeared as dark patches in the photos. What started as a side effect of a solar mission turned into a real breakthrough. It clearly showed how tightly the surface and atmosphere interact, and that the heat from the blazing rocks really does reach the upper edge of the cloud layer. We keep uncovering more evidence that beneath the thick clouds lies a complex chemistry and active geology. But what if all of this is just the prelude to one recent announcement that shook the scientific world? An announcement that seriously suggested for the first time, life? In the fall of 2020, the scientific community was jolted. Not by a siren, but by a quiet, persistent signal that traveled across trillions of kilometers of empty space and through gigabytes of digital noise. A team of scientists, working with the two most powerful radio telescopes on Earth, the Atacama Large Millimeter Array and the James Clerk Maxwell Telescope, were studying the spectral lines coming from Venus. They searched for chemical fingerprints in its atmosphere. What they found shouldn't have been there, under no circumstances. The data revealed a ghost, a faint but clear trace of a molecule known as phosphine. In that moment, Venus stopped being just a hot, lifeless ball. It became a crime scene, and phosphine, the smoking gun. To grasp the scale of this explosion, you first need to understand what phosphine means on Earth. It's not just a gas, it's a smell. Sharp, unpleasant, like rotting garlic or spoiled fish that lingers in the harshest corners of our planet. The bottoms of swamps, inside animal guts, in oxygen-free mud. Anaerobic microorganisms produce it, simple life forms that don't need oxygen. Phosphine is basically their exhaust. Earth's geology doesn't make this gas in significant amounts. Volcanoes don't erupt it, and lightning doesn't create it. It's a byproduct of life. Now, this very gas, the chemical whisper of biology, has been detected where we thought nothing could whisper. Finding phosphine on Venus is like walking into a sterile operating room and suddenly smelling campfire smoke. There could be many explanations, but the first one that comes to mind makes your heart race. The news spread worldwide, sparking a storm, not just of excitement, but of skepticism. This is how real science works. Bold claims demand rock-solid evidence. Yet the phosphine signal was faint, like a distant echo. Other research teams rushed to point their telescopes at Venus, eager to replicate the discovery. They couldn't. Some detected traces, but far weaker. Others found nothing at all, arguing that the original team had mistaken phosphine for interference from a simpler compound. Fierce debates erupted, and they still rage today. This isn't a failure, it's science in its purest, most ruthless form. What could be the greatest discovery in human history might turn out to be just a calibration error. Or it might not. And that uncertainty fuels the tension you can feel in every observatory across the globe. The mystery of phosphine didn't appear out of nowhere. It built on groundwork already in place. Just 1 year earlier, in 2019, scientists revisited an old hypothesis while trying to explain the mysterious dark spots that have hovered in Venus's clouds for decades. These spots, as large as entire countries, drift through the atmosphere and behave oddly. They absorb ultraviolet light intensely. The new theory proposed these might not be mere chemical oddities, but massive floating colonies of microorganisms. These organisms could be using ultraviolet radiation as an energy source, much like how Earth's plants harness visible light. The idea sounded like a daring flight of fancy, but after phosphine showed up, it no longer seemed so far-fetched. Two very different clues, and one chemical, one visual, suddenly pointed in the same direction. Life in clouds made of sulfuric acid. It sounds crazy, until you check the temperature and pressure map of Venus's atmosphere. It turns out even hell has its oases. We spent all this time looking for life in the wrong place. We stared down at the scorching surface like a frying pan and found nothing but hell. But what if the answer wasn't under our feet at all? What if it was above us? The whole concept of the habitable zone turned out to be too narrow, too tied to our earthbound experience. We searched between planetary orbits at the perfect distance from the star. But life might exist within a single world. Not on the ground, but in the sky. Venus, a planet of extremes, hides its most important secret, not deep below, but high above. Between 45 and 60 kilometers above Venus's scorched surface, something strange happens. Something that shatters everything we thought we knew about the planet. The pressure there matches one Earth atmosphere, the same as at sea level in places like Miami or San Diego. Temperatures range from freezing to a surprisingly comfortable 122 degrees Fahrenheit. This isn't just bearable, it's a kind of paradise. A thin 15-kilometer layer squeezed between two extremes. The freezing void of space above and a blazing furnace below, where a person could survive without a pressure suit. They would only need oxygen and protection against acidic droplets. This is the zone where liquid water can exist, where complex molecules remain stable. A potentially habitable region, hovering in the skies of hell. This scientific reality gave rise to a dream that sounds like science fiction, but rests on precise calculations. Floating cities, massive airships filled with ordinary Earth air, a mix of nitrogen and oxygen. In Venus's dense carbon dioxide atmosphere, this gas outperforms helium, lifting enormous structures according to Archimedes' principle. These airborne stations could drift forever within a comfortable layer, never falling into scorching heat or rising into freezing cold. Scientific laboratories hovering in the clouds of an alien world. Not conquest, but coexistence. Not an assault, but a graceful glide in the only place Venus has made livable. And then suddenly this wild idea explodes to a cosmic scale. Venus stops being just our strange neighbor. It becomes the gateway to thousands of other worlds. In recent years, astronomers have been discovering new exoplanets at a staggering pace, about one every single day. The galaxy is flooding with planets, and a huge number of them are super Venuses, worlds similar in size and mass to our morning star, orbiting close to their suns. By studying their atmospheres with the James Webb Space Telescope, we search for chemical fingerprints, biosignatures, oxygen, methane, even phosphine, signs of life trillions of kilometers away. But to understand what these signals truly mean, we need a standard. A Rosetta Stone for decoding alien skies, and that stone lies right here next door. By unraveling the mystery of life in Venus's clouds, we might unlock a universal key to finding life across the entire universe. New missions are already on the drawing boards, ready to dive into Venus's clouds and search for signs of life. But to understand Venus's future, we first have to unravel the final mystery of its past. The puzzle of why a planet with such a fiery temper lacks a heart. A magnetic field. A planet without a heart. This is not just a metaphor, it's a diagnosis. Earth's magnetic field forms an invisible shield, born deep within its core. Its spinning, molten metal core acts like a colossal dynamo, generating a protective force that deflects the deadly solar wind. Venus, by all calculations, also has a liquid core, but the secret lies in its slow, almost motionless rotation. The dynamo exists, but it barely works. The engine has stalled. Without rapid spin, there's no strong magnetic field. And that's one of the greatest tragedies of our sister planet. Its entire atmosphere, its whole world, stands defenseless against the sun's fury. But the story of exploring Venus is far from over, and it's only entering a new phase. On drawing boards right now, the next chapter is taking shape. The Russian mission called Venus D. Its goal isn't just to touch down on the surface, but to stay there for a long time. They want to build the first ever long-lasting station on Venus. Just 10 years ago, this would have sounded impossible. Today, breakthroughs in high-temperature electronics are changing the game. Engineers are designing microchips and sensors that can operate at 470 degrees Celsius. Electronics that don't melt in hell, but treat it like a normal workspace. Alongside this, nearly forgotten but elegant ideas for Venus rovers are making a comeback. Not heavy-tracked monsters, but lightweight sailcraft that harness hurricane-force winds to glide across the scorching plains. Scouts drifting along the currents of an atmospheric ocean. Scientists stay grounded. Dreams of terraforming Venus, turning it into a second Earth, still belong to pure science fiction. The challenge isn't temperature or pressure, those could, in theory, be changed. The real problem lies in its sheer mass. Venus's atmosphere weighs 90 times more than Earth's. It's a vast ocean of gas that has to go somewhere. But where? Space offers no dump for excess atmosphere. The scale of the task is staggering, like trying to drain the Pacific Ocean with a single bucket. It's a beautiful idea, but physics won't bend. For the foreseeable future, Venus will remain just Venus. That's where its greatest value lies. Venus isn't a failed version of Earth. It's an alternate reality, a vivid textbook in planetary science. Venus reveals what happens when the greenhouse effect spins completely out of control. It stands as a ghost of our possible future, frozen in stone and gas right next door. Every new probe, every byte of data, goes beyond studying a distant world. It's an effort to better understand our own. By studying Venus, we don't diagnose the planet, we diagnose ourselves. Venus serves as the perfect laboratory for testing climate models and holds the key to unlocking the mysteries of thousands of similar exoplanets we discover every year. Behind all the complex calculations, behind the titanium and ceramics of spacecraft, and behind the debates over phosphine and cloud cities, lies something incredibly simple: curiosity, the fundamental human drive to understand how this universe works. It all begins with a single bright spot in the morning or evening sky, with a child's straightforward question: what is that shining up there? Our entire body of science, every mission into space, this vast Odyssey, it's all an attempt to answer that question fully. And within that simple desire, from a tiny point of light to grasping an entire world, lies the greatest adventure of our species: